hot air rises from the first floor, it gets trapped by the ceiling in this foyer and actually can naturally ventilate out a window up high near the ceiling. These are called a clerestory window. We have multiple units here in a bank to allow us a massive amount of convection. So if you were to open a window downstairs and leave these open, just the natural heat rising would cause a natural flow of air throughout the house. Right. So we bring air in from the side of the house, the north side of the house, with the least amount of sun, bring in the coolest air. We leave these windows open, allow the hottest air to escape, and the house itself will ventilate and cool naturally, also minimizing the amount of air conditioning needed.
Right, so it's basically breathing now.
We make the house, make the airflow through the house on its own naturally. Right. The one other feature that we have that you cannot see right now, but in the attic, we have solar powered fans too. And what happens is the sun comes out, starts to warm up the attic, it starts that solar powered fan running, and that fan in turn at the top of the ridge line sucks the hottest air out of the attic, and in turn cooler air gets replaced and drawn in, so the attic constantly ventilates. It works like an old-fashioned ridge vent, only with the assisted power of the fan. It doesn't cost anything to operate, it doesn't cost anything to maintain. The sun shines, the fan runs. And it's that
zero maintenance.
Zero maintenance. And by taking that hot air in the attic off the second floor, we also minimize the heating and cooling load on the house.
Great. So Dean, let's take a look at this thermal envelope you've been talking about, this double-studded wall.
Well, if you look carefully at this wall system, you can see there's a row of 2x4s in the front, there's a row of 2x4s in the back. What this system does is it stops heat and cold from transferring through the 2x4s. This area is always got 4 inches of insulation between this stud and the exterior. This one here always has 4 inches of insulation between the exterior stud and the interior. What that does is that allows the same amount of insulation to be about 30% more effective. Now the fact that we've doubled the thickness of it, the minimum wall thickness in this house is 8 inches, twice the thickness of a conventional home built to code. And as we go to 8 inches thick and we go way beyond the old 2x4 wall, the thicker we get, the more efficient we've packed this insulation in, the better insulation we use, which is a compacted cellulose, the more efficient that the system becomes. So 8 inches of insulation, although it's twice as thick as 2x4, it's actually 10 to 12 times more effective as you increase the thickness of the walls. Right. So in essence, this house is built like a giant refrigerator or a cooler, and it's meant to resist temperature change. It's a myth that you hold heat in and you keep heat out. We actually try to build the house to resist temperature change. The center walls are filled with a mass product that actually anchors, it's called a thermal anchor. So that dense gravel and gypsum mass that goes in the interior walls actually stores heat in the wintertime and absorbs heat in the summertime. And that thermal anchor also keeps the house more of a consistent temperature. Stabilizes it. Right. So what we're trying to achieve here with the thermal enveloping and the thermal mass in this house is we want a house that resists change in temperature, or it changes very slowly from season to season. So as the seasons change and the different days fluctuate, the inside temperature and the comfortable ambient temperature in this house stay consistent from day to day, and it doesn't swing. So on a really hot day, this house will heat up 10 times slower than a conventional home would, and in turn, when the seasons change from fall to winter and we get the cooler weather coming, the interior temperature of this house will stay warmer longer.
So, and some of the problems I know in traditional homes is that you might find areas of hot pockets and cold pockets, but when you're talking about this thermal mass wall and with the tightness of the envelope, you shouldn't have any of those issues, right?
We don't. And the other thing we do is we use a system called an equalizer. And what an equalizer does is it allows an air channel from nearby each bedroom door to the hallway. And what that does is that actually allows any unbalanced airflow from the air system to transfer from the room to the hallway. So you don't get a room that actually has an increased volume of air versus a room with a decreased volume of air, and it makes the entire house heat evenly. On the first floor, we have an open concept, so the airflow tends to travel right through the house far more efficiently. On a second floor where we have all our bedrooms and we have much more walls and the rooms are much more demised, at that point we then use equalizers to allow the airflow to obtain an equilibrium from room to room to room and ultimately to the hallway, and that keeps the upstairs heating evenly.
Wow. So Dean, tell us a little about the layout, how many bedrooms we have here. Let's go over some of the basic statistics.
Well, right now we're in the master bedroom,
Great.
and this house also has a sub-master. In this bedroom here, we've got a 14-foot cathedral ceiling. It's all wired and set up for ceiling fans. We use a lot of ceiling fans throughout the house. Oversized walk-in closet and dressing room, and it has a galley-style master bath.
So what we have over here, we have the vanities here.
We have a double vanity. We have a double vanity going here. We have the soaking tub, jacuzzi tub in the middle. And although it's not in yet, we have a hand-built ceramic tile with a stone base shower unit built on the end, a Florida-type shower. And what we've done is we've created a galley, and it allows us a full 5-foot runway from one side of the bathroom to the other while all the working components are on the opposite wall. And it allows a much nicer flow in the bathroom, and it allows you to have 2 people pass and function in the bathroom without being cramped and without having a maze to get in and out of things.
So this is a self-facing area of the house. And now you're talking about the thermal mass earlier. Would this be a thermal mass
This
wall?
would be a thermal mass wall opposite the south-facing windows, capturing some of that solar energy in the wintertime. And the overhang on the house is designed to block some of that solar energy from entering the house in the summertime.
So this is going to be filled with some kind of product.
Filled with a thermal mass product that will actually keep the temperature in this room here.
Great.
Our same premise is minimizing what we need. So we minimize the amount of artificial light needed. To further enhance that, we use occupancy sensors in bathrooms and hallways. So as you travel through those areas, the lights automatically turn on without you touching a switch. And then as you leave those areas, the lights turn off. So there's very, very little wasted light. We use all CFLs in a high efficiency lighting package. And a home this size should probably expect a minimum 50% reduction in an monthly electrical bill just with the safety packages and the efficiency packages that we use.
And plus, if you have children, having lights come on and off by themselves is always a nice thing, right?
Kids can't leave the lights on in the bathroom anymore. All right, we're going to leave the master bedroom now and the master suite, and we're going to go down the hallway and check out the rest of the bedrooms.
All right, let's go.
Here's bedroom number 1. Every bedroom here is a sizable walk-in closet, substantial amount of windows and natural light in each room. And let's go down the hallway. We have the main bath, central to the other 3 bedrooms. Right here. We have bedroom number 2. Bedroom number 2 has an east-facing clerestory window, bringing in some high sunshine into the room. It has an oversized walk-in closet, and it has a beautiful south-facing double window to both light up the room and provide some solar thermal heating in the wintertime.
Nice sized room.
Yeah, let's go to the submaster.
So we have cathedral ceilings in this one as well, huh?
Yeah, this room is the submaster, and in this room here we have a double window in the front. We have a nice east-facing window. This room actually has 2 closets. It has an oversized walk-in closet, it has an additional secondary closet, and it also has a cathedral ceiling similar to the master.
Great. So Dean, tell me about this I-joist system that you have going on here.
We use what's called a TGI, which is a manufactured I-joist. And what that does, that allows us much more flexibility than conventional framing. It's much more dimensionally stable. The floors come out straighter. They come out more level. They come out much more rigid. And we can actually span over 26 to 28 feet with them. So we have a 28-foot kitchen without a single column or a bearing wall to obstruct it. In the back of the house here, we have a 56 by 20 plus foot clear span from the kitchen to the living room, allowing us a massive amount of usable living area that flows from one room to the next without any bearing walls or columns in between.